Good morning. Does it work? Everyone can hear me? Nice. Okay. So
Oh, it doesn't matter.
let's see. Richie, how do I even move your cursor? There's no mouse.
It's on the right-hand side.
Huh?
Es sind zwei Bildschirme. You are moving the mouse.
Ah! Okay, see? I'm just not smart enough. Okay. Wow. Okay, I always mirror, so I'm not used to this. Okay, perfect. So welcome to PromCon, first talk. I'm Julius, one of the co-founders of Prometheus, and now I'm just Prom Labs. I'm just a one-person company doing trainings and courses around Prometheus. And a while ago, what do I hit? Okay. Okay, interesting. It doesn't, okay. I need to actually, can I not mirror? Then, there it is. Okay, perfect. So I'm testing the room for you. Okay, so originally I wrote a blog post in July, and because I saw some issues with people using OpenTelemetry with Prometheus, and then I joked and said like, hey, I could do a PromCon talk about it, and the joke was accepted, and now I'm doing the talk. So you could also read the blog post for more detail if you want to. So OpenTelemetry is here in full force. I would say it's not going to go away. People want to use it with Prometheus, right? Like they want to instrument the services with OpenTelemetry, and then the metrics part of it they want to send to Prometheus. But honestly, I have to say there are plenty of downsides in comparison to using Prometheus's own native instrumentation client libraries. So I want to talk a bit about those downsides, and you should at least be aware of them before choosing to go down the OTel route if you mostly care about metrics and Prometheus. Disclaimers. I'm a Prometheus co-founder, so I'm like super duper biased towards Prometheus, of course, towards the Prometheus way. And there can still be valid reasons, potentially, for using OpenTelemetry with Prometheus even. But there are plenty of other talks and PR start pieces and everything on the internet talking about why you want to do that. So this talk is just not going to cover that again. We're also going to have more talks today and tomorrow about OpenTelemetry and Prometheus. And I want to commend everyone on working on that compatibility and making that work as good as possible. It's just this talk isn't that. So, but still props to everyone working on that and making that good. So quick contrast between the two systems, as probably most people in this room will know, Prometheus aims to be an entire monitoring system. Gives you tools to track metrics in your systems, then get them out of your processes, store them, query them, even have like alerting facilities, dashboarding, although that's usually done with Grafana. But it aims to give you like a tool chain for the entire purpose of monitoring some systems, but only one signal types, only metrics. In the contrast, OpenTelemetry only cares about generating the signals and then processing them a little bit and just passing them on to some kind of third-party backend system. But it does it for more than one signal types: logs, metrics, traces, and now also profiles. It's pretty new, I think. And this makes sense because it was like a bunch of companies coming together. They already had their cloud observability solutions, and they said, we want to standardize on the ingestion part and like the generation of signals, but then we all want to offer our own differentiated observability solutions to store and further process those metrics. So there's some overlap, obviously, right? The overlap is in the metrics and the transfer pieces of the puzzle, right? And both OpenTelemetry and Prometheus have their own client libraries and protocols for first tracking metrics in a process and then also sending them somewhere, right? On the OpenTelemetry side, it's OTLP to send those metrics via push. That's the transfer part. And then in Prometheus, we actually pull them with a text-based format. So obviously, people came and said, well, but I want to use OpenTelemetry because I can do all my signal types with it, and everyone's doing OpenTelemetry now. So let's just do that. And maybe we can still get our metric part from OpenTelemetry into our Prometheus server somehow. And a common way of doing that is you could directly send OTLP to a Prometheus server from an application, but usually in the OTel landscape, you first send all your signals to an intermediary process, the OTel collector. It collects them, it processes them, and then it allows the collector to either send those signals on to some backend, or for Prometheus, also in case of this Prometheus exporter box, to even go and scrape the collector. That's not ideal. If you want to do that, you probably want to nowadays go for that lower OTLP exporter box here, where the collector can directly send those signals to an OTLP receiver endpoint in a Prometheus server. But there are downsides of going this route, like basically downsides to using OpenTelemetry, SDKs, and protocols in that first part of the chain. The first one is something that I find really unfortunate, which is that you're really throwing away a lot of what makes Prometheus good and capable, which is this integration of service discovery with a pull-based active target monitoring. Right? Like fundamentally, a monitoring system should know what the world should look like and what it currently does look like, and then tell you about the difference. And then you need to know all the different processes that currently should exist in a highly dynamic world, all your pods, all your dynamic cloud VMs, and so on. Otherwise, you can't tell if something's missing or broken. Prometheus solves this with two things, right? Service discovery and active pull. That's this famous Prometheus architecture diagram, and just the highlighting of those two aspects here. So service discovery helps us know on a continuous basis what processes we should monitor and what their identities are with labels and so on. And that can change all the time, right? For example, Prometheus can be talking to a Kubernetes API server to get an always up-to-date view of what should exist in the world. And then based on that information, Prometheus goes out and it actively tries to pull or scrape metrics from those endpoints. And it records this up metric with a value of 0 or 1, telling you whether the scrape succeeded or failed. And then you can have very nice per target health alerts. You could also have aggregated alerts and so on, but you have this up metric that tells you really if there's anything missing in the world. And OTel doesn't really have a built-in facility for this, so this gets harder, right? Like, how do you tell that a target's maybe running, but it's not sending you metrics? How do you know that if it's down and it's also not sending you metrics? Or there's network failure, or you even could have the opposite case where some random thing, some intern's job that they just started is sending you metrics, and you're not expecting that if you don't have some security controls in place. And pull and service discovery automatically avoids that. So a lot of people, I think, just ignore this completely, and they just send random metrics to their Prometheus server or some other backend system, and treat it as a random receptacle of metrics, and they don't know if there's some process that should be running but isn't. So I think that's a bit of loss, and I would be sad to see that totally go away. Now, I heard this idea, I don't know how, someone knows maybe how far the work on this is, or if it's happening, that there could be a synthetic up metric in the future for OTLP ingestion, where there's still some service discovery going on, and then it gets correlated with incoming data, and you get some up metric generated when some expected data doesn't come in a 5-minute period or so, but it doesn't exist yet. So currently you have to completely manually correlate some data in PromQL from some source of truth to make something similar happen. Reason number two, you end up with these either changed metric names or somewhat ugly PromQL selectors, and usually it's both. So, first of all, you have these character set differences where OpenTelemetry also includes some characters that were not supported previous to Prometheus 3. Like dots especially in the metric names, but also it allows slashes and some other operator-like characters in the metric names, and to me that kind of signals that people standardizing this for OpenTelemetry didn't have as a high priority that a metric would actually be used like in a query language, for example, that already has operators and where you then need to care about escaping. So this is a bit hairy. And then the second thing is that in Prometheus, in our naming conventions, we like to add suffixes for both units and types of metrics to immediately clarify to the reader what those are, right? Especially if you have a long PromQL expression somewhere in a big YAML file with tons of metric names, you don't maybe have access to a UI that tells you metadata about each metric. So it's really nice to have that as part of your metric names. OpenTelemetry doesn't really have this, right? They say like, don't put unit and type into the metric name. We just track that as separate metadata fields, which is really cool as well. But again, only really works when you have access to that easily. So by default, our ingestion layer, when OTLP comes in, we actually add back, like we look at those metadata fields and we add back those suffixes when translating the names. So with the character set differences and those suffixes, the default translation looks like this. You get dots replaced by underscores, and you get these units appended, and now you may get a little bit confused about these metrics looking quite different from where you write them in your instrumentation and where you use them in your Prometheus server. And yeah, with native instrumentation, this doesn't really happen that much, right? You can configure this now. You can like say, I want to keep the suffixes or drop them, or don't do any translation now because Prometheus 3 does support full UTF-8 in metric names and attributes or labels. But if you do keep those characters, then you do have to live with more ugly PromQL selectors. So the usual selector for metric name in PromQL would just be the metric name, and then in curly braces some further label selectors. And now anything that has this extended new character set needs to be moved into the curly braces, even the metric name, because otherwise the parser wouldn't know that it's just not a normal string. And it just, yeah, in my opinion, it's not as nice as our selector before, but this was a necessary compromise due to this clash between operator-like characters or yeah, and strings and so on to make the parsing possible. Number 3, we have resource attributes and target labels in both systems. They're similar concepts, right? They're a set of key value pairs to tell you more about a resource that is sending metrics. But they kind of work a little bit different. In Prometheus, the target labels, they usually come from service discovery. They're relatively few, they're relatively identifying. And so you usually just stick all of them directly onto every time series that comes from a target, which is handy because then you can directly see them and reference them and filter by them. In OTel, these resource attributes, they're very numerous. And although they're technically all identifying, I think there's like a lot of extra information in there, like the OTel SDK version and the language and all these things. So usually you don't want to stick all of them onto every time series scraped or coming in via push from these resources. So then what we do in the ingestion layer by default, again, you can configure this, is only map these really like the job and instance over from the service name and service instance ID. And if you want to have access to more of these resource attributes, you need to join them in either using this new info function or a manual PromQL join with a binary operator, which gets cumbersome. You write longer PromQL expressions. Again, something you don't really have to worry about if you use native instrumentation. Now, yeah, it's all configurable. You can promote more resource attributes if you need to, but that's the default. This is more of an FYI, not a big downside, I would say, but there are more Prometheus settings you need to fiddle with to make it fit to graft it onto OTLP and OpenTelemetry. First of all, you need to actually enable this OTLP receiver in the Prometheus server, right? Because normally Prometheus only pulls and you can't just push stuff to it. It would be a little bit of a security concern. But here you have to just allow that, and then you need to, of course, somehow restrict that endpoint to only people who actually should be able to push there. You also have to allow appending samples within a given time window out of order, because usually when Prometheus pulls, it does it on its own timestamps and it just appends within a time series always. But OTel doesn't have these guarantees. Samples can arrive out of order, and the TSDB now has facilities to allow that, but they still need to be enabled. So 30-minute window here is probably a good idea at least. There's some other settings like, OTel can have not only the cumulative counter temporality that we have in Prometheus, where counters always just go up and up and up. They also have this model where you say, I want to report in delta temporality, where you only send those increments in every reporting period that happened in that period. So like every 15 seconds, just send me the counter increments from that period. And some people can't, even when they're sent to Prometheus, they have a hard time just switching over to cumulative temporality. So Prometheus is starting to, support this. There's an experimental delta to cumulative processor. There will be a talk about it later also. But it's again one more thing you have to think about. Yeah, there's a whole page about this, how to use OpenTelemetry with Prometheus with more settings at this URL here. Then a big one again, in my opinion, is just OTel and its SDKs are quite complex and can be quite slow, depending on maybe what language you look at. But even just learning all the concepts, I think, takes longer. There's more data types, there's more concepts, there's more convolutions, there's aggregations, there's views, and all these things in the instrumentation library. And as an example, I looked a bit at SDK performance in Go, and I think, instrumentation library performance does really matter, especially if you have some high performance, multi-core web server or something that does a lot. You don't want to worry about instrumentation taking a significant amount of CPU or memory when you want to measure what it's doing. So as just an example here, I did a Go benchmark for just incrementing counters in both the Go native Prometheus client library, so that's client Golang, and then the the OpenTelemetry SDK. Ran it on my desktop, relatively powerful desktop at different levels of parallelism, and you get this, right? So if you just say like counter.inc or add or something in a loop, then depending on the level of parallelism, you get up to 22 times faster in our library because we're like super duper optimized to fast counter increments. Similar performance with histograms, potentially other metrics as well, but just like setting these metrics. This is a counter with no labels on it, so just simple inc. If you do add 2 labels, then it's still like 90% slower. This is actually after some fixes were already applied to the OTel SDK. So this is based on the current main branch of the OTel SDK. It was, I think, a little bit slower even before. And then the Prometheus client library also has another facility where you can actually get a hold of a given like specifically labeled child of a group of metrics, and then you can cache it and reuse it, and then it's even faster. So, anecdotally, looking at this, I was even trying to find out where does this counter increment happen in the OTel SDK. In the client Golang of Prometheus, you find it in 5 to 10 seconds, like F12, jump to definition, and like, oh, it's there. And then in OTel, I gave up after 5 minutes. I couldn't find it because and this is not to say anything bad about the people writing that SDK, but there's so many concepts and views and aggregations and indirections the sample needs to go through before it arrives somewhere that I was like, okay, maybe I'll try to find it another day. I couldn't find that actually line of code yet, but I also haven't tried super hard. And then, yeah, I would also say, so this is less of a performance thing, but the complexity of Prometheus and the exposition format here is also that we have like this super low hurdle. You don't even need an SDK if you don't want one. You could just expose a simple line of text from a text file, and then you can scrape it with Prometheus, and that gets harder with OpenTelemetry, because then you need to implement this protocol buffer-based format, and probably you want to use a client library for that. Small caveat here, nowadays you need to set like either one more header on this HTTP server to say what content type it's serving, or you need to set like a default scrape content type on the Prometheus server to make this specific example work. But yeah, point still stands. Reason number 6, very short one, right? A big reason for people saying, but we have to use OpenTelemetry is because it's like the one big open standard that everyone is doing now and standardizing on now. But I would at least argue that Prometheus is also very open. It's open source. It has an open governance like OpenTelemetry. It's in the CNCF. It's very mature and battle tested. Also, basically, everyone uses it. And all these interfaces we have in Prometheus, not all of them, the alerting protocol, maybe not so much, but PromQL, the remote write protocol, our metrics transfer exposition format, they're like almost de facto standards in many parts of the industry. Like most of the cloud vendors have, offer PromQL now or a remote write way to get metrics in there and so on. Right. So, closing thoughts. This is not to say that there shouldn't be reasons to use, OpenTelemetry with Prometheus, and you'll hear more of them, of course, later in the conference. But I did want to point out the drawbacks of doing so and maybe make you think about, okay, do we really want to go down this route if you mostly care about metrics and using them with Prometheus? So yeah, and also in terms of like the service discovery and SDK slowness drawbacks, I would really like other people to think about that more and maybe improve things, to not just throw away the baby with the bathwater and lose all these benefits that we built very carefully in Prometheus over a long time. So thank you very much. Do we have time for questions?
I think so.
Okay, there's one. Basti, yeah. Do you have the microphone? Let me just get a water.
Thank you so much for the presentation, Julius. That was really interesting. So let's say on the OpenTelemetry, if they want to, make some corrections that they are working, for example, on functions for Kubernetes, do you think it will be interesting for them to work on something similar for Prometheus? Like you said, anyway, it's not yet.
Conventions?
Yeah.
Interesting. Yeah. You mean like naming conventions for metrics,
Exactly.
right?
Yeah.
And sorry, just.
Yeah, no, go ahead.
Okay, that was it. Yeah. I think so. Could be potentially interesting because people were even wondering, what we even like in OTel is semantic conventions, and we kind of regret not having those in Prometheus land from the beginning. It was maybe too early, and we didn't have the power to do that and the knowledge. And could it still make sense to introduce something similar now? And of course, we have these millions of exporters with established metric names, so it's going to be a little bit harder. But it could still make sense, especially for something like Kubernetes, where it's like this entire project saying we standardize on this naming and so on. I think that could totally make sense. Yeah.
Perfect.
Not an expert on that, but yeah.
Yeah, I mean, obviously down the road probably will be like a collaboration between Prometheus and OTel people. But besides this, because like you said, like OpenTelemetry is not going away, so it is here to stay and obviously mature. Do you think of any other, let's say, improvements you might suggest to them besides the semantic conventions, like something like really important? That pops in your head.
Improvements in Prometheus or in OTel?
In OTel.
Oh, in OTel. Yeah, I mean, definitely get the SDKs more performant. I think that's a big thing for me. I think the complexity you can't really get rid of anymore because it's just so baked in now. It's going to be like the XML or Corba of telemetry. For better or worse, right? Like trying to solve all the problems at once, which has, I totally get it, but it means that you have to sift and wade through way more concepts than you maybe need in the end. So it's hard to get rid of that part, probably. Yeah.
Yeah, I mean, I'll give you an idea to write a sequel for your blog post and just say for OTel people like what you can improve, and put down some technical stuff because obviously we will need to work on it, both sides.
Yeah.
Yeah. Perfect. Thank you so much.
Thank you.
I have a question, please, on high dimensionality context, high context. You called out that there were a big difference between Prom and OTel on the resource attributes. on you rightfully called out that resource attributes in OTel are a bit messy because some are identifying, some not, some we don't know really until whatever happened. But do you see Prometheus adding more contextual label, more metadata to help slice and dice metrics or explore your data? Or do you see?
Do you mean for OTel metrics?
No, for the Prometheus, do you see Prometheus ecosystem supporting more contextual metadata labels to enable exploring in unplanned ways your
for targets? So the thing is that in Prometheus is very much like up to the administrator and the type of service discovery. The service discoveries often already offer a lot of metadata labels that you can choose to map in all your time series if you want to. But I guess what we don't have yet is like an equivalent to the target info, but for SD, where it's like, okay, don't map all the service discovery metadata into every time series, but map into one time series for this target that we can join in if we need to. Or does anyone of the Prometheus team have any comments on that? Probably not, right? But like already, the service discoveries do give you a lot more metadata that usually doesn't all end up um, in every time series of a target. But it's of course not everything that OTel gives you, and it's not coming directly from the source that you're pulling from. It's coming from service discovery, so it's a little bit of a different source of knowledge, right? So I guess the advantage that OTel has is like it can more locally inspect its process state and say like, oh, I'm running in this type of machine, and I'm this OTel SDK version, and all these metadata fields that are more easy to glean when you're like locally inspecting the state. But I haven't heard of like big efforts to make to push.
Yeah, I think something I like on OTel is that attributes are qualified as resource or as metrics attributes. So when you do visualization to make it human readable, as you said, if there are too many, it's not human readable. On this qualification helps.
Yep.
So maybe Prometheus could
to have like a split between the two officially.
Yes, in visualization.
Yep.
Yep. Thank you.
Okay. We're out of time.
I mean, if there's more questions.
Okay.
Also, as a reminder to everyone, please try and keep more to the question side of things. Any last questions? Thank you very much.
Thank you.